Okay, so how do we use ImageJ to quantify by image analysis bands on a protein gel or a DNA gel or any other gel that you want to work on? Even a chromatography sheet this would work on. But the ImageJ program, you need to obtain that. Look up ImageJ. It's basically evolved from what used to be called NIH Image, and it was at that time written for different codes and different platforms, and then once it got programmed into Java, it's usable on a lot of different systems now. ImageJ. This is a color image taken just with a camera in a phone, and this is a fine image. You can adjust your image and save it with another program if you want. If you need to get the maximum, say, contrast, you would like fairly light or white background compared to the bands you're interested in. In this case, we have a standard here for a protein and a bunch of fractions of a related version, modified version of the protein that we've purified and run off of basically a heparin cephalose column here. And we'd like to get an idea of how much protein we have in the gel. So the first thing we have to do in ImageJ is make this what is really a grayscale 8-bit image. And so under image type, you can see this is an RGB color image. It basically needs to be converted to an 8-bit image, and you can see it goes to grayscale. And so this is where we can use ImageJ. Now we can use basically this rectangular tool, and we'll also be using these gels tools under the Analyze menu. And we're going to basically set up a bunch of little rectangular selections and select a bunch of lanes, get a plot of them, and then find the areas really plotted from peak to peak. And then you can just take these numbers and put them into a spreadsheet, and you've got an image analysis that's just fine as anything else you're going to be able to do with any program. So the first thing we do is we have a rectangular selection tool, and I'm probably going to make sure I'm going to have one at least this wide. These bands here are a little bit wider and show the lane, and I want to get all these other lanes in. So what I might do is start off over here and get a lane that I can work with here. And you can just sort of click and hold in the middle, and I can move that around. I make it a little bit skinnier. And often I'll put the band I'm interested in. In this case, there's really just one band per lane. If you had a complex sample with many peaks, of course, you might want to start this all the way up at the top of the lane and go down. This is a molecular weight standard ladder here. So once you have the first one selected, you go to the Analyze menu, and you can either use a quick key function. In this case, there's the command 1, command 2, command 3. Those keys can be used to do these menu options, or I'll just use the menu options here by selection so you can see what's happening. And we just basically will select the first lane. And then you want to basically copy this to all the other lanes. And ideally, this feature wants to have this rectangular selection the same dimensions, width, and height everywhere else you use it. And you just basically, if you go to the number and click and hold, you get another copy of it, and you can just move it over to the next lane here. And this time you go down to the gels, you go select the next lane, just like that. And then you just continue this process. Select the next lane. Boom. Now you've seen that, what I will do is I'll speed this up a little bit, and I'll use the command number 2 on my keyboard to just keep doing the selection of the next lane. So I click, hold, and drag off the number, command 2, select the next lane. Select the next lane again, and again, and so on. And that completes that process. So once those are selected, the next step is we will go to gels and we're going to plot the lanes. Before we do that too, one thing I'll also show you is if you ever want to check out these gel analyzer options, I won't change them now, but you might find that depending on the graphic file you get, you may find that when you do the next step, plotting, you get valleys instead of peaks. You can still work with valleys, but if that really bugs you, come in here and click on invert the peaks. In my case, that's the default. So those are fine. So the next step is go to gels, plot the lanes. Boom, and we've done that. Move this over a bit. So basically from lane 1 and 2 and 3 and 4 all the way down, you can see the plots of each lane. And going down an entire rectangle, what you have at each position, so vertically in each position, if that's really considering that along here, is your x-axis is along the gel from top to bottom, and then intensity, and it's really taking the average intensity of that whole horizontal line and giving you a plot here. And so this is pretty reasonable. Really in analytical type chemistry, if your noise to signal ratio is 3 to 1, you basically have a usable signal. This is probably down about the minimum. This is fine. Here's a standard on here and some other unknown samples or fractions from the column. And what we want is the area under this peak, because they will be proportional to the amount of stained protein on the gel. So the next thing you can do is use the line tool, and you see it's already flipped to the line tool for us, and you just literally go over here and draw a line across, just like that. And I'm going to do that for each one. You can take your time, think about where you want to put these, but think about where you feel your baseline may or may not be. But we just go through here and add these. If you're doing this and you click more than once and you make a mistake and make an extra little line piece, reset and start again, or you'll get some very weird results. But you'll see the next step, how this works. Okay, once those are drawn in there, then you go to analyze again, gels. Oops, no, we don't do that. We actually do something easier. We go over here up to the selection tool menu again, and here is like the magic wand tool. So you're literally going to click this. You're going to click now inside the area we're interested in. And if it's done it correctly, you'll see it yellow outline is showing you what it thinks you want to select and what the pixel area is under that little triangular section. So you want to see that the yellow goes all the way around and doesn't go anywhere else. And every time you click this, the magic wand tool, you are getting the area of that region placed over here. So as you can see, the areas are here for all the peaks, and they basically all make sense. Generally look at your numbers, see if they make sense. 6, 7 should be the largest ones here in area, and they looks like they are. Everything kind of looks fine. 2 we can see on here is a fairly dim band, and it's definitely the lowest. And there's no crazy numbers in here that have jumped outside. If all of a sudden you saw, say, in this group 60,000 or 100,000 or something, what I would guess is you've kind of clicked funny and got a strange result somewhere. And actually, you can see that has happened down here. This last one, it didn't quite get the line where I wanted it, but that's just because you can actually click around live. So there you go. So if you get the wrong area, just click it. Now we're all adjusted correctly. everybody should be fine. So you can just keep doing these. It'll keep adding them though. So if it just gets crazy, you can go up all the time without hurting anything to gels, to reset, and just get rid of everything, and you can start the whole process again if you want. You can save measurements, not save them. Once you have that table, you can cut and paste it into Excel. In this case, I would use the standard with a known amount of protein to make a conversion factor, and then just use the conversion factor to turn all of these other areas into an amount of protein. And that is basically how you can get the data you need from ImageJ. Thank you.